Hello?
Good afternoon, everyone.
Good afternoon.
Before we begin, I would like to request everyone who has logged I would like to request everyone who has logged in to please make sure that your names are the same as the ones with which you have registered for the webinar. There are possibly several names which are appearing as the names of your mobile phones, perhaps. So please make sure that you take the opportunity right now to rename those names and register online appear online only as your names. Thank you. Good afternoon. Once again, I would like to request those who have logged in to please make sure that you are logged in with the name with which you registered for the webinar. For example, I can see at least two participants, one of which is registered with Vivo 1907, another with QCOM as their login name. Please make sure that you rename yourself at this point. Thank you.
Good afternoon, Professor.
Good afternoon, Pali sir.
Yes, sir, Professor. Good afternoon. How are you?
Good afternoon, Priyanka madam.
Good afternoon, sir.
Priyanka madam.
Good afternoon,
Yeah.
sir. My sincere welcome to all the delegates and speakers. Once again, formal announcement to everyone to please make sure that they rename themselves according to the name with which they registered themselves for this webinar. And also, please note that as you can see in the chat section, there is a link given for the live streaming of this webinar on YouTube, which can be accessed from the link given there as well. Please also note that within the next 3 minutes, we will also be starting the program at 3 p.m. Thank you.
Yeah. Good afternoon.
Good afternoon and welcome everyone. On behalf of IIS deemed to be University, I welcome you all to the inaugural session of the 2-day international webinar on scientific writing organized by the Department of Chemistry, IIS deemed to be University, Jaipur, in collaboration with the Association of Chemistry Teachers, Mumbai. Before we begin, I would like to repeat a few of the announcements. Please log in with the name with which you have registered for the webinar. If you do not know how to do so, please rename yourself immediately. Also, please note that all questions will only be taken at the end of the second technical session. And also, the live screening link is available for you in the chat section, which may be accessed at any point of time. Before we commence with today's proceedings, let us raise our voices to ask for divine blessings from the Almighty. Welcome. From the moment of its inception, 15 years ago, as the International College for Girls in 1995, IIS deemed to be university has reached many significant milestones in its endeavor towards excellence in higher education. An A+ accreditation by NAC UGC and recognition by a model college by the state government and as a college with potential for excellence by the UGC are some of the highlights of this ongoing journey. It was granted autonomy by the UGC in 2007 and has now been conferred the status of a deemed to be university by the Ministry of Human Resource Development, New Delhi, placing it in a Category 1 amongst the top 33 deemed to be universities of the country. Cognizant of its responsibility to future generations, IIS deemed to be university has consistently organized and held several major conferences, symposia, and collaborative events over the years to broaden horizons and avenues for its staff and students for the purposes of academic self-improvement. It is an honor for us to host today the two-day webinar in partnership with the Association of Chemistry Teachers, Mumbai. Established in the year 2000, the Association of Chemistry Teachers is in its 20th year of dedicated service to the academic community, putting faculty development and the promotion of innovative teaching practices and research at the forefront of its manifold activities. The ACT has organized numerous seminars and workshops as part of a series to foster research-based skills amongst faculty members, researchers, and students. The challenges enforced by the current pandemic have been answered by webinars such as this one, taking the work of the ATC beyond borders and reaching out to a global audience in a common mission towards a common goal. Francois Arago once said, "To get to know, to discover, to publish, this is the destiny of a scientist." Keeping this thought in mind, we welcome you to this webinar, which provides a platform to introduce the participants to the different approaches of scientific writing, plagiarism, and scientific misconduct. It will not only help them build their subject knowledge of chemistry, but will also enhance their ability to communicate science with a focus on writing different types of manuscripts, reviews, and project proposals. With this, may I now request our Honorable Chancellor, Dr. Ashok Gupta, to kindly deliver the welcome address.
Namaskar. Professor Brajesh Pare, President ACT, Professor D.V. Prabhu, General Secretary ACT, ACT Executive Council members, ACT members, speakers, senior professors who have joined from India and abroad, delegates from India and abroad, Vice Chancellor, Advisor and Dean, IIS deemed to be University Jaipur, faculty, research scholars, postgraduate and undergraduate students from IIS deemed to be university and other restaurants. I extend a very hearty welcome to all of you today when we are organizing the international webinar on scientific writing, which will be held on 27th and 28th November by the Department of Chemistry in collaboration with the Association of Chemistry Teachers, ACT Mumbai. It's a great moment as we would have Professor Georgi Keglowicz from Budapest University, Professor Martin D. Root, University of Wisconsin, Professor Sandeep Verma, Secretary SERB, Professor Ayan Dutta, School of Chemical Sciences, Kolkata, Professor Masaki Yoshu Fuji, Professor S.D. Samant, Professor R.K. Bansal, and many other luminaries in the field of chemistry. As earlier informed, IIS University is among the pioneers in Rajasthan in imparting quality education in various streams. The journey which it started in 1995 as a girls' college with just 52 girls and 7 staff members has grown into a banyan tree. Since then, it has seen significant growth and success, leading to its eventual accreditation by NAC as an autonomous college with an A+ status. In 2009, the Ministry of Human Resource Development, Government of India, declared International College for Girls as a deemed to be university. Subsequent to the screening by an MHRD constituted committee to review the functioning of deemed universities, I take immense pleasure and pride in stating that we are amongst the first 38 universities which meet the norms and standards of the MHRD and make constant efforts in maintaining those ideals. IIS deemed to be university is also known for excellence in delivering value-based education to students and encourage them to think innovatively. Our curricula and teaching learning practices serve to guide students across all academic domains in realizing their individual potentials, as well as preparing them to become world-ready citizens who are well equipped to take professional and social challenges with an educated and empowered mind. The emergence and rise of scientific knowledge has long been held as a mark of human achievement, development, and upward mobility. In pre-modern times, whatever scientific knowledge existed was safeguarded and kept secret. The transition from the system to one in which scientists are encouraged to share their findings and insights as widely as possible is primarily responsible for the flourishing of science and its development by leaps and bounds over the past several centuries. As a result, it has become increasingly vital to establish corridors and forums for effective scientific communication. Scientific writing is not simply to write about science, it is an organized technical form of writing that is designed to communicate scientific information clearly and concisely to other scientists. Such efforts allow for information to be shared in a transparent manner, which proves beneficial for everyone. The aim of this webinar is to introduce the participants to the different facets of effective scientific writing, common grammatical errors, and scientific misconduct. It will not only help them to build their subject knowledge of chemistry, but also enhance their ability to effectively communicate their research according to universally accepted parameters. I'm very pleased to share with you that this webinar, organized as part of ACT's Research Convention series, has received very good response, and more than 1,200 delegates from India and abroad have registered. The Department of Chemistry has been able to put together a very impressive lineup of experts as speakers to help ACT, its members, and other delegates to learn about scientific writing. I'm extremely thankful to ACT for having joined hands with us for the motivation of the young students and research scholars to undertake more research opportunities and for fostering research skills in them. This webinar will witness interactions between young and experienced researchers to take stock of the current scenario and future directions in chemical research. The 2 days of deliberations will, I'm sure, enrich the young minds and motivate them to readily step towards and be active participants in the future of chemistry and research. I once again welcome all the delegates, scholars, faculty members, and participating students to the webinar and wish it all the success. Thank you and welcome.
Thank you, sir. May I now invite Professor T.N. Mathur, Honorable Vice Chancellor, IIST to be University, to please say a few words.
Respected Chancellor, sir, and greetings to one and all. It gives me immense pleasure to extend my warm wishes on behalf of IIS University. It gives me tremendous contentment to be saying few words amongst the most esteemed personalities who are the experts in their respective fields. Before we begin, I would like to express my gratitude to all of you who sincerely committed to this event to make it a success. This event would have been impossible without support of each and everyone present here. A good scientific paper provides a comprehensive understanding of the study and also communicate that how it fits into a larger body of knowledge. Besides this, the purpose of writing is to sharing ideas, keeping a record of progress, explaining a process of our system, and also sharing the results. In this webinar, an individual is given a platform to identify their understanding, focus on essential aspects of different approaches in scientific writings. I hope on conclusion of webinar, it develops scientific reasoning for quality writings and also contributes to global scientific knowledge. At the end, I convey my gratitude to the speakers for accepting our invitation over the webinar. With best wishes, thank you all.
Thank you, sir. I would now like to invite Dr. Rakhi Gupta, National Convener, Association of Chemistry Teachers, and Registrar, IIST to be University, to kindly elaborate on the Research Convention 2020.
Thank you, Priyanka. I think there's an echo, so I need to correct that. Sorry about the technical glitch. Honorable Chancellor of the IIS University, Dr. Ashok Gupta, Professor T.N. Mathur, Honorable Vice Chancellor of this university, Professor Brijesh Pare, President, ACT, Professor D.V. Prabhu, General Secretary, ACT, Executive Council members of ACT, speakers who have been able to join today, Professor Keglowicz, I can see, Professor Masaki Yosifuji, I can see, and others who have not been able to join in absentia. Professor S.D. Samant, I think, has joined. Professor Bansal has joined. Then our Dean, Professor Pradeep Bhatnagar, delegates from India and abroad, and my dear colleagues. Namaskar. On behalf of the organizing committee of the IIS University and the ACT Research Convention 2020, I once again extend a hearty welcome to you all to the International Webinar on Scientific Writing. It is indeed a matter of great privilege for our university to host yet another program of the Association of Chemistry Teachers, Mumbai, the first being the NCCT convention in the year 2014. Let me share with you the genesis of this mega series. In the last Executive Council meeting of the ACT in February, which was held in Mumbai this year, the idea of holding a research convention took seed. And it was eventually decided that in keeping with the new education policy and Education 4.0, the association would organize more research-based programs to foster research skills amongst faculty members, researchers, and students. As a result, the work towards an annual research-related and research-centric convention entitled Research Convention 2020 was begun. The topics that were shortlisted ranged from identifying a research problem, the instrumental methods of analysis, scientometry and organic synthesis, to scientific writing, research data analysis, and IPR, so as to cover the step-by-step process of conceptualizing and conducting quality research. Once the topics were finalized, it was decided to organize a number of seminars, workshops, and conferences as part of a series for exploring different and allied aspects of research. Of course, at the time of conceptualization, it was planned to organize these events in the offline or physical mode. But then COVID-19 struck us, and how? The online mode was then adopted to navigate the unprecedented times of the pandemic and go beyond the prevailing crisis. Though it came with challenges, but the virtual medium also gave us an opportunity to go global and make these events international in nature and stature. I'm very happy to share with you that the idea of the Research Convention 2020 has eventually evolved wonderfully and successfully despite the pandemic. We have already conducted 4 events with much success too. Today's event is the 5th in the series, and there are 2 more to go. The forthcoming ones are on organic synthesis and intellectual property rights, which are again scheduled in December. By way of these webinars, ACT has been successful in accomplishing its mission of promoting chemistry education and research in India, and in giving an additional fillip to capacity building of chemistry teachers and students. The Research Convention is thus on its way to becoming yet another flagship program of ACT, an additional noteworthy feat in its eventful and illustrious journey of 2 decades. Having shared with you the genesis of the convention, I now take this opportunity to thank and acknowledge all those who have helped transform the idea into reality. I would like to begin by thanking our Chancellor, Dr. Ashok Gupta, who has always supported us in each of our endeavors to promote and strengthen the fabric of teaching, learning, and research. It is only because of his positive outlook that all of us at the IIS University are able to carry forward the mantle placed on us. I would also like to thank Professor Pare, President ACT, Professor Prabhu, General Secretary, Professor Samant, former President ACT, and the entire ACT Executive Council members for their invaluable guidance in meticulously planning the entire program. Special thanks go to all the conveners of the various events who came forward at our behest and accepted the offer of organizing each one of those. I'm sure with their complete involvement and total dedication, the Research Convention series would be a big success. For today's event, my sincere thanks need to be conveyed also to Professor T.N. Mathur, the Vice Chancellor, the Advisor, Professor K. Sharma, and the Dean, Faculty of Science, Professor Pradeep Bhatnagar, for their able mentorship and hand-holding all through. A very special thanks to Professor Bansal, who is, by all means, the architect of today's program. I also take this opportunity to thank Dr. Pragya Sinha, head and convener of the program, Dr. Manisha Patni, organizing secretary, as well as my department and university colleagues for their wholehearted support and ready help extended to us in organizing this event. With these words, I warmly welcome and thank today's speakers and, of course, tomorrow's speakers also. Professor Georgi, Professor Martin, in fact, this is his vacation time, but still he made it a point to record his lecture to be shared with us, and Professor Sandeep Verma, who would also be delivering a lecture today, for sparing time to share their research journey, insights, and key learnings with us. I close by wishing you all an information-packed and insightful learning experience over these 2 days. Thank you and welcome once again.
Thank you, ma'am. I would now like to call upon Professor D.V. Prabhu, General Secretary, ATC, to please say a few words.
Hello, am I audible? Yeah.
Yes, sir.
Yes, thank you. Good afternoon, faculty and delegates from India and abroad, and dear friends. We are about to begin the ACT webinar on scientific writing. This is one of the important webinars in the ACT Research Convention, which we started this year as a new activity. This webinar will be of great use to researchers, teachers, editors, and science writers, as it will address several aspects of scientific writing, such as how to publish a research paper, how to write a project, how to write a thesis, editing, to name a few. We are very proud and happy that several eminent experts from India and abroad will be delivering talks. And some of these eminent people are editors of very prestigious journals of high impact factor. On behalf of the Association of Chemistry Teachers, which has entered its 20th year of service, we would like to welcome all these eminent speakers and the delegates to this webinar. Let me say a few words about ACT. ACT is very proud to be a part of this webinar. It is a national organization of chemistry educators of India and started way back in 2000, and it is completing 20 years of dedicated service to the chemistry educators of this country. And to mark this occasion, a special souvenir is been brought out under the editorship of Principal Dr. Umesh Chandra Jain. Since its inception, ACT has been pledged to promote excellence in chemistry education and research, and has been organizing several activities at the national level and sometimes at the international level. Some of the activities are organization of conferences, training workshops, and symposia all over our country. Organizing chemistry competitions for school and college children. The organization of concept tests in chemistry for BSc students, which is possibly the only competition for BSc students in our country. Involvement in the Indian national and international chemistry Olympiads by way of selecting the team, training the team, and sending them abroad. Annual National Convention of Chemistry Teachers, which we call NCCT. This year's NCCT will be in the virtual mode due to the COVID pandemic. I invite all of you to NCCT 2020, scheduled for November 29-30 and December 1, 2020, under the able convenership of Professor Prem Mohan Mishra, who is the president of our East Zone. In the past, ACT has organized international conferences on chemistry and chemistry education in collaboration with the Royal Society of Chemistry, London, and the Department of Science and Technology, New Delhi. This year, we have initiated 2 new activities: a workshop on designing quality questions, keeping in mind the International Olympiad in mind, and the ACT Research Convention, which has been mentioned. Both activities were very successful, and there was a large number of participants taking part in both the activities. Every year, ACT honors the distinguished chemistry teachers of India with the prestigious ACT Awards, and these awards are given during NCCT, which is held annually. ACT has a large network of active life members and institutional members, and all the eminent chemical scientists of the country are honorary members or patrons, including Bharat Ratna Professor C.N.R. Rao, the most eminent scientist of India. The ACT newsletter can be accessed on our ACT website and gives you information about the activities of the association. ACT also gives academic support to a peer-reviewed chemistry journal, Globalized Research Journal of Chemistry, which is abstracted and indexed in Chemical Abstracts, CAS, USA. No fees are charged for publication of papers. I request all of you to become the members of the ACT. The life membership fee is only 1,500 for a lifetime. I once again take this chance to welcome all our delegates and our eminent faculty to this webinar and wish the webinar grand success. I would like to thank Professor Rakhi Gupta and all her colleagues for their dedicated efforts to organize this webinar. Thank you very much.
Thank you, Professor Prabhu. May I now invite Professor Brijesh Pare, President ACT, for his presidential remarks.
Yeah, thank you, Dr. Priyanka. Good afternoon to one and all. I'm audible, Priyanka?
Yes, of course, sir. Absolutely.
Yeah, thank you. So, Professor Ashok Gupta, the Chancellor of IS University, Professor D.V. Prabhu, General Secretary, Association of Chemistry Teachers, Professor T.N. Mathur, Vice Chancellor, IS University, Dr. Rakhi Gupta, the Rector and the Professor, and the Secretary of SCT from Central Zone, I mean, playing the pivotal role for this program, Professor Bansal and Professor S.J. Samant, all SCT Executive Council members, staff of the IS University, and all the colleagues across India. Really, I'm so much delighted. You know, this is the 6th program in a series of our ACT Research Convention. And this is for the first year, as Professor Prabhu has mentioned it, that we are doing it, the ACT is doing it. And what I understand, you know, this is probably the first of its kind, this program designed and being executed across the country. I once again congratulate IS University to organize such a wonderful event in collaboration with SCT. It's really an international event. For this program, we are blessed to have the stalwarts from across the globe and to speak on this occasion. Just a coincidence that the COVID-19, you know, the pandemic has really made this research program more significant and more visible across the globe. As you know, Dr. Rakhi has also just told that this program on scientific writing is, I mean, the whole of this, our SCT research program, going to benefit particularly our master students, the research scholars, and early in service faculty members also, those who are into research and particularly this program of scientific writing is really of very significance. What I mean, see, look at into that the scientific writing is not just writing about science. It is the technical writing that the scientists do to communicate their research to others. And the scientific writing is predicated on the rigors of scientific inquiry. So it must reflect the same precision as the demanded in the research process. So scientific communication demands precision, then clarity, and of course, economy. This distinction is an important one because the writer is communicating highly technical information to others who might or might not be as knowledgeable. They may be from a different discipline. They may or may not be the native speaker of the language used. Many journals have international audiences, and so precise communication helps prevent misunderstandings and mistranslations in other contexts. So, I mean, this is really very important. The communicating the facts and figures and the methods used in the research has to be very precise and exact. So, without going into the much details of the nitty-gritties of this subject, because we have really a wonderful, the battery, rather the galaxy of speakers for this 2 days program. So, once again, I congratulate Dr. Rakhi, I congratulate Dr. D.V. Prabhu for organizing such a wonderful program. I congratulate the whole of the IS University, and particularly the dynamic Vice Chancellor, Professor Ashok Gupta, for this event. And thank you very much. And I just wish all the best for this program, and hope we are going to have a very detailed and very meaningful deliberations today. Thank you very much.
Thank you, Professor Pari. With this, we come to the end of the inaugural session of the 2-day international webinar on scientific writing. I would like to extend my immense gratitude to everyone for sparing the valuable time and for attending the session. Thank you all. We now move straight into the first of 3 technical sessions over this 2-day webinar. We are pleased to host 3 eminent speakers today, the first of which is Professor Gregory Keglowicz, who hails from the Department of Organic Chemistry and Technology, Budapest University of Technology and Economics, Hungary. He is also the Editor-in-Chief for Current Organic Chemistry and Current Green Chemistry, the Co-Editor-in-Chief for Current Catalysis, Associate Editor for Current Organic Synthesis and Letters in Drug Design and Discovery, and the Regional Editor for Letters in Organic Chemistry. Graduating from Technical University of Budapest in 1981 as a chemical engineer, he became Doctor of Chemical Science in 1994 in the subject of organophosphorus chemistry. He has been the head of the Department of Organic Chemistry and Technology since 1999. Within organophosphorus chemistry, his major field embraces p-heterocycles involving selective syntheses, as well as bioactive and industrial aspects. He also deals with environmentally friendly chemistry involving MW chemistry, its theoretical aspects. I'm sorry, I'm facing a light. I'm sorry, I faced a small technical glitch. He also deals with environmentally friendly chemistry involving MW chemistry, its theoretical aspects, phase transfer catalysis, the development of new chiral catalysts, and the use of ionic liquids. He is the author or co-author of about 550 papers, including about 70 review articles and 40 book chapters. We now welcome Professor Gregory Keglowicz to speak on the title, Development of Results During Research Selected Examples from Organophosphorus Chemistry.
Yeah, Professor Georgi, you can share your presentation now.
I think he's not online. Is it possible to check? Raki?
Can you hear me?
Yeah,
Yeah.
Professor Georgi. Yeah, you're here. Yeah.
And can you see my presentation?
You'll have to unmute, Professor Georgi.
Can you see my presentation?
Yes,
You
yes.
are one of the co-hosts, so you can unmute.
Okay, so
We can't hear you.
you can't hear me.
We
Can you hear me?
Raki.
Your
Yes.
audio is on, but we can't hear you.
No, I can. We can hear. I can hear.
आवाज आ रही है?
आवाज आ रही है?
Maybe
Raki?
you reconnect with your audio on.
I can also hear.
Can you
We
hear
can
me?
hear.
Can
We
you
can
hear
hear.
me?
Yes, yes.
Yes,
Okay,
yes, sir.
so you can hear me.
Yeah.
Good afternoon. Thanks, Priyanka, for nice
Professor
introduction.
Georgi, you'll have to reconnect. Your audio is not on.
No, no, it is
We
on.
can't hear
Raki.
you.
Raki, it is on.
Not connected with your audio.
No,
Raki,
no,
it is on.
I was connected. I was connected, and a part of the audience can hear me.
Yes, yes. You please go ahead.
So no
Georgi?
problem. No problem, I guess.
On hai, but
Ma'am,
can you reconnect?
मैम आवाज आ
Can
रही
you
है सर की?
reconnect?
Raki,
No
आवाज
need.
आ रही है?
Only you cannot hear me. Everybody can hear me, I guess.
Yes, yes, yes. Please
Yes,
go
yes.
ahead.
Okay,
Georgi.
so
I can hear.
okay, so good afternoon. Thanks, Priyanka, for nice introduction. Dear Chancellor, Dr. Ashok Gupta, dear Chairwoman, Prof. Raki Gupta, dear Vice Chancellor, Prof. Mathur, General Secretary, Prof. Prabhu, President, Prof. Par, Professor Banzal, ladies and gentlemen. I am grateful for the invitation of the Chairwoman, Prof. Dr. Raki Gupta, and my friend, Professor Dr. Raikumar Banzal. Frankly, I was a little bit surprised on the topic of this conference, but gradually I made friends, and eventually I was glad to be able to contribute to the subtopic of scientific misconduct. I am from the far Budapest, Hungary, located in mid or East Europe. The time shift is 4.5 hours. I chose the approach to show how the scientific results are developing. From this, it follows that at the start of a project, we know less, and after certain periods of time, we shall know more and more. It is also a possibility that during the years passing, the conclusions have to be refined. I wish to intimate you in 3 independent case studies. Okay. The first case, it is the contents. The first case is on an assumed double ring enlargement. The second example is on the refinement of the mechanism of the fragmentation-related phosphorylations. While the third topic embraces a misled on the mechanism of the nickel-catalyzed PC coupling reactions. All the 3 stories are connected with their own research topic. With their own research. So let me change for the first case study. This is on a so-called double ring enlargement of 3-methyl phospholene oxides. Here you can see the 3 phospholene oxides. They can be reacted under forcing conditions with dichlorocarbene generated.
So can you please share your screen?
It is not shared. Georgi, it is not shared.
Can you hear me or can you see me? Please tell me what the problem is.
We can see you, but we cannot see your presentation. We cannot see the slide. You have to click share screen. Yes, yes. Yeah, that's right. That's great.
Okay, sorry. So in the first case study, we reacted phospholene oxides with dichlorocarbene under forcing conditions. Forcing conditions mean that we used an excess of dichlorocarbene, and dichlorocarbene was generated from chloroform by 50% sodium hydroxide under phase transfer catalytic conditions. And the dichlorocarbene adducts were obtained in excellent yields. And also, in the second step, we subjected these dichlorocarbene adducts to thermolysis, and we obtained a mixture of double bond isomers of so-called 1,2-dihydrophosphinin oxides. And in the second step, these dihydrophosphinin oxides were reacted again with dichlorocarbene, again under phase transfer catalytic conditions, and we got these intermediates, but these were only intermediates, and we didn't separate them, and then they spontaneously underwent a ring enlargement. So this is a nice reaction when the 5-membered ring is expanded to a 6-membered ring, and then in another reaction, the 6-membered ring is expanded to 7-membered phosphapine oxides. So all these are very interesting phosphorus heterocycles. Then we expanded the reaction to dimethyl phospholene oxides. In the previous slide, there was only one methyl group. In this case, there are 2 methyl groups. And this tiny difference made a huge difference. So we reacted them again with dichlorocarbene. We got the adduct. Here is the ring expanded product. And it reacted further with an excess of dichlorocarbene to give this adduct. And then we believed that we obtained symmetric phosphapine oxide. And this was a prelimination communication, and it is very interesting that this adduct underwent a spontaneous ring opening of the cyclopropane moiety. So we could not isolate this kind of adduct or dihydrophosphate oxide. This was just the one-path reaction. Okay. However, 2 years later, we were successful in getting a single crystal from the phenyl, p-phenyl substituted product. Here is the single crystal structure. And surprisingly, the compound was not the 7-membered phosphapine oxide, but the 6-membered 4-dichloromethylene 1,4-dihydrophosphinin oxide. So we were really surprised that we made a mistaken assignment. Then we were very careful and extended the reaction and characterized the products with carbon-13 NMR. And indeed, there were 2 quaternary carbon atoms of a very low intensity. That was the problem. At that time, the NMR instruments were not so sensitive, and it was difficult to observe the quaternary carbon signals that were of very low intensity. And then we made, we cleaned up the problems, we eliminated the problems, and this reaction was even extended to alkoxy substituted compounds. Here you can see a series of compounds were described in heteroatom chemistry. At that time, heteroatom chemistry was a major journal for organophosphorus chemistry. This journal was founded by Bill McEwen. He was my good friend, the late Bill McEwen from Massachusetts in the United States. And the European editor was Alfred Schmidt-Peter. Professor Banzal educated with Professor Schmidt-Peter. So it was a prestigious journal. It is an unfortunate issue that this journal was taken by Hindavi, and I am still some kind of editor at Heteroatom Chemistry, but it became an open access journal, and for this reason, it doesn't work properly. So let me tell you some kind of problem with regarding publication. This was a very good journal, and right now it is working not with full intensity. Okay, parentheses are closed. The message of this experience, what I was speaking about, is that one should be very careful with the preliminary publications as a conference proceeding or as a short paper. It is natural that the results are refined during the completion of a research project. It is also noted that these days the instrumental background is much developed, hence the chance to commit a mistake is smaller. However, let's say in the 70s, entirely superficial papers lacking spectroscopical evidence were published. Not seldom, these articles are misleading, not speaking about the publications born in the first half of the 20th century or even in the 50s. Still, we can recall papers where there are simply not spectroscopical characterizations, just assumptions, and this may cause a problem. Okay, let me go to the second case study. In the next story, bridged phosphorus heterocycles are the main actors. 3 phospholines may be converted to phosphoroxides that react immediately with dienophiles, like in a general formula here, to furnish 7 phosphonorbornene derivatives. It is noteworthy that the anti-aromaticity is the driving force for the regio and stereospecific disulfide cycloaddition reaction. Irradiation of the alcoholic solution of the phosphonorbornene led to the corresponding phosphonic acid right here in red. The ejection of the bridge aryl phosphinoxide moiety was assumed that was trapped by the alcohol. By a Williger oxidation of the 7 phosphonorbornenes provided the corresponding oxaphosphobicyclyl 2,2 octane derivatives that on heating ejected metaphosphonates. These low coordinated fragment phosphorylated the alcohol present in the medium instantly. This kind of chemistry was explored not only by me, but also by Professor Quinn. The third kind of fragmentation involves 2 phosphobicyclo 2,2 octane derivatives, shown here, prepared by the disulfide reaction of the 1,2-dihydrophosphine oxide I showed you earlier, species, and the dienophile. And that can be an N-phenylmaleimide or dimethylacetylene dicarboxylate. In this case, methylene phosphine oxides are the low coordinated fragments or reactive intermediates that were utilized. I guess this is a very nice piece of chemistry. First, let me intimate you how the precursors were prepared. Dihydrophosphine oxide was this is some kind of diene, was the starting material, and as I mentioned, they were reacted with dimethylacetylene dicarboxylate or N-phenylmaleimide, and you can get here you can see here the adducts. And also, it was possible, and it is very interesting, that 2 units of the dihydrophosphine oxide could react with each other, behaving as a dienophile and the diene. So the dimers of dihydrophosphine oxides were also prepared by us. And here are the fragmentation-related phosphorylations, or these were summarized. It's very interesting that certain energy had to be input. Then the precursor is fragmented, and the low coordinated fragment will phosphorylate the nucleophile. That may be an alcohol or an amine. So in this way, in the first case, we carried out photolysis at 254 nanometer, and we got the phosphorylated products. And also, not only alcohols, but amines could be used for the preparation of this simpler species. It was also possible to perform this reaction under thermal conditions, and here we got similar results using, for example, phenols. Finally, and this was a recent, rather recent finding, that microwave irradiation, we are also dealing with microwave irradiation. So microwave irradiation also affected the fragmentation, and we could trap the low coordinated fragment to get the corresponding starting material, as the corresponding product. It is a very important scheme. Here you can see that this is the classical route, that the blue moiety of the molecule will be ejected, and phthalate derivative as well, but that is the byproduct, and then this reacts with the nucleophile. And we discovered from different experiences that not only this mechanism can be imagined, but another one, in the first step, the nucleophile is added on the phosphorus atom of the PO group, and then this adduct will be decomposed to afford the final product. So the first mechanism is an elimination addition. Second mechanism is the addition elimination mechanism. And we proved it applying sterically hindered model compound, and it was obvious that this mechanism, a competitive component of the occurrence of this kind of reactions. So we believe both mechanisms are present. And with my Polish friend, the late Professor Stefan Jankowski, we proved by isotopically labeled water, O18 water, we could prove that indeed the adducts are being formed. I guess the time is passing, so I cannot go into details, but believe me, that key intermediate reverted back, and double isotopically labeled product justified the formation of this kind of pentavalent, pentacoordinated intermediates. Okay, we arrived at the third case study. But sorry, the conclusion of the second study is that the originally assumed elimination addition mechanism does not describe the reality, as the alternative addition elimination route may also be relevant. It is probable that the situation is not black and white, and both protocols are present in different proportions. We were glad that we could expand the horizon of this interesting reaction. Moreover, the addition elimination mechanism may also be valid for the reactions of the oxaphosphobicyclooctane precursors. It is known that photolysis of simple phosphorus heterocycles takes also place via pentacoordinated intermediates, as suggested by Professor Tomioka in the 70s. With the presentation of the above story, I wish to show that the scientific results can never be considered unchangeable. The situation is just the opposite. There is everywhere a constant development. All scientists should be open for the newer developments, accepting the state of art of the particular field. The publications should reflect the continuous developments. For this reason, the comprehensive review articles working up certain periods of the particular fields are rather important. Okay, and now I really can change for the third case study. It is a new observation of course that microwaves may make possible the simplifications of certain reactions. The hero reaction is the phosphorus carbon coupling of an aryl bromide with a POH reagent that can be a dialkyl phosphide, for example, in the presence of palladium tetrakist biphenylphosphine, or palladium acetate as the precursor together with mono or bidentate phosphorus ligands. It was experienced by us that under microwave conditions, there was no need to add an extra P ligand, no need for extra P ligand, as the PC couplings took place in the presence of some excess of the P reagent. How is it possible? Please don't forget that the P reagent has a tautomeric form, and the trivalent form can act as a P reagent. So the PC couplings took place in the presence of some excess of the P reagent. Or method elaborated may decrease the environmental burdens and also the costs, as there is no need to add special P ligands. The PC coupling reaction could be extended to other P reagents as well. You can see here, like alkyl phenyl H-phosphonates or secondary phosphine oxide. So this was quite general reaction. Okay. What are the real in situ formed palladium zero catalysts in the palladium acetate catalyzed Hero reactions? The formation of the bisligated palladium complex shown in the right left corner from palladium acetate and the POH reagent was confirmed by theoretical methods. Explicit implicit solvent model was used, and we clearly proved that this is the catalytically active form. So the excess of the POH reagent here, or the tautomeric form, may serve on one hand as the reducing agent. It reduced the palladium 2 to palladium 0. On the other hand, via its trivalent tautomeric form as the P ligand. And the third role was that it was the reagent. So that for this reason I mentioned that we had to use in some excess. And also here is the energy diagram for the formation of just the catalyst. It's very interesting that the ligation also has an importance. It was a fully surprising experience that steadically hindered aryl groups, phosphines. For example, the 3,5-dimethyl phenyl phosphine oxide, or even the 2-methyl phenyl bis aryl phosphine oxide was more reactive in the reaction than the diphenyl phosphine oxide itself. Why? Because of the ligation. Because if there is steric hindrance, only this bi-ligated species can be formed. But with the smaller phenyl group, you will get also the tri-coordinated complex, even the tetra-coordinated complex. So the steric hindrance prevents the formation of the tri- and tetra-coordinated complexes and promote the activity of the catalyst. So it was very interesting. This is another story. And then we calculated the mechanism of the Hero reaction. This was the model you can see. And here is the classical circle for such catalytical reactions. It's comprising the usual 3 steps: the oxidative addition, ligand exchange, and reactive elimination. So this is the usual way for the CC coupling reactions as well, but here we are speaking about the PC coupling reaction. Actually, the Hero reaction was discovered in the 70s, so it is practically 50 years ago, and a very interesting reaction. And here is the energy chart for this kind of reaction. I'm not going to go into details. I just mentioned that here quantum chemical calculations proved as well the presence of the palladium 2 palladium 0 conversion. And it was interesting that the reaction could be extended also using nickel salts instead of the palladium salts. It is a separate topic if palladium salts or nickel salts should be used. Price and toxicity are working against each other. So we could use nickel chloride as well, and the same reaction was practically observed. But, and it is very important, regarding the mechanism, we were the first in the literature that we noticed that not a nickel 2, nickel 0 transformation is responsible or in the background of this transformation, but nickel 2 to nickel 4 transformation. So it was a very strange and unusual experience. So the nickel surely was not reduced to nickel 0. Instead, nickel 2 was oxidized to nickel 4. This is an interesting observation of ores. And here is the enthalpy diagram belonging to this mechanism I was speaking about. And approaching to the end, it is a recent finding of us that the nickel 0 catalyzed reductive versions mean a dead end street, let me say. So quantum chemical, my colleague Zoltán Mucsi tried to calculate this mechanism and suffered a lot because it was not possible to continue this mechanism as a nickel 2, nickel 0 route. It was so unfavorable energetically on the energy surface, so he had to fail. And for this reason, it was proved that it is not, it is an impossible way for this kind of reaction. So I guess we proved very carefully also experimentally, but I could not intimate you in this aspect, that all hero reactions catalyzed by nickel involving the mechanism of nickel 2, nickel 4. Okay. So at the same time, in the literature for the mechanism of the nickel catalyzed phosphorus carbon couplings, the nickel 0, nickel 2 protocol was generally accepted. Even great phosphorus chemists, giants, assume this. So our invention, a new approach suggesting the nickel to nickel 4 conversion, was somewhat groundbreaking. On the one hand, the chemical society was misled regarding the nickel catalysis of the hero reaction. On the other hand, we have to fight hard with a concurrent referee who insisted on the nickel 0 version. This raised serious ethical problems. The conclusion is that if the chemical society accepts a thesis that turns out to be false, it is rather difficult to have it changed. Even the inventors may get in a situation that the publication of their innovative results is delayed or even prevented. Unfortunately, not all editors have the wisdom of being able to decide correctly. Dear colleagues, ladies and gentlemen, this is my final transparency. Let me show you my immediate colleagues. I have a bigger group, but these ladies and the gentlemen took place in the results I presented for you. Thanks for your kind attention.
Finished.
Yes.
Thank you, Professor Georgi. Can you hear me?
Yes, 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 yes.
Thank you so much. Wonderful talk. Very interesting.
Thanks.
Rakhi, it is over now.
Thank you, Professor Keglowicz, for your insightful comments on the topic of organophorous chemistry. We are all greatly enriched by your presentation. Thank you.
Sure.
We welcome next Professor Martin D. Rudd, who joins us from the University of Wisconsin, Oshkosh, USA. He is an active member of the American Chemical Society, serving as the Northeast Wisconsin's local sections counselor, and was admitted as Fellow of the Royal Society of Chemistry in 2011, as well as being named an American Chemical Society Fellow in 2018. He is also an editor-in-chief of Phosphorus, Sulfur, and Silicon and the Related Elements, published by Taylor and Francis since 2008. He obtained his PhD in 1994 from the University of Warwick, England, and is currently Assistant Chancellor for Access Campuses at the University of Wisconsin-Oshkosh. He will be speaking today on getting your research published. However, since Professor Rudd is at home enjoying a family vacation, Thanksgiving. He is joining us today by means of a video lecture. I now hand over to our technical team for the video presentation by Professor Martin Rudd. Thank you.
Greetings, everyone. My name is Martin Rudd. I am a professor of chemistry at the University of Wisconsin-Oshkosh in the USA, and also the editor-in-chief of Phosphorus, Sulfur, and Silicon and the related elements. And I'm honored to spend a few minutes with you today to try and help you understand a little bit more about how to get your research published. I've got a few slides that I'm going to be going through that are mostly based on the experiences that I've had in my role as editor-in-chief for the last 12 years or so, that I hope will be useful to you as you embark on a career that involves scientific writing and what ultimately I hope are successful submissions and publications. The reason I'm not with you live today is because it is the Thanksgiving holiday in the USA. So for today's talk, I've broken some topics up into some understandable themes that include the process of getting your scientific research ready for publication, how to prepare your paper in general, some guides for you as potential new authors, and then in particular some responsibilities that I like to have as a journal editor and that you should have as authors. I also want to provide you with some tips on how you can be most successful in getting your research published. And I'll talk about some of the things that I look for as a journal editor in scientific writing that I know will help you as you begin to create your writing. So the first topic I want to cover is even determining when your research is ready for publication. There are a few basic things that I would suggest that you ask yourself in order to determine if your research is ready for publication. So first of all, in general, young scientists are working with a dissertation or thesis advisor, and they're often the first place where you should go to find out if your research is ready. I was a young researcher at one point too, and it can become a very fraught process trying to understand how to get your research published. You're often eager. You're often wondering, when can I get my first or my second paper published? But we want to make sure that all of that is done in the right way. So often your dissertation advisor is a great place to start. Another really useful place to start is if you've had the opportunity to present your research at conferences, whether that's at a webinar-based conference over the last few months, or maybe prior to the COVID lockdown at an in-person conference. Often at those conferences, either after your presentation or maybe at a mixer session, you might be able to solicit some feedback about your particular presentation from attendees, and they can provide some good critique for you, not only about what they heard and saw, but with good ideas about how to expand the science, for instance, or whether the work may be publishable as it is. Another good question to ask yourself is, are you the person who has permission to write and submit the paper? Sometimes you're not working on your own. Sometimes there's a group of people that are working on the research. Perhaps you are the one who is tasked with writing the paper, or perhaps you'll be tasked with doing parts for the preparation of the paper. But either way, you need to make sure that you have the permissions necessary in order to be able to submit the work to whatever format you decide to do that. And again, that relationship with your dissertation supervisor or research group leader is an important one. I'll use a little less than a scientific term here, but you need to know what the story is that you're going to tell about your research. A research paper is often a very condensed way of telling a scientific story about a project or ongoing research that has taken place. And some of the questions you want to ask yourself is, when somebody reads that story, will they see it as being original? In particular, your work will need to be novel. And is it fully developed? Has it come to a natural end, or is there still more work to be done on it? And these are some of the things I'll talk about a little bit later from an editorial perspective. And perhaps the final item I want to touch on here is, what are you prepared to do if your work is rejected or needs to be resubmitted? Part of the decision-making process that's made by journal editors after the peer review process may be to offer a decision that rejects the paper or encourages you to resubmit it after doing some additional work. You have to ask yourself, what additional work are you prepared to do? Are you anxious to get out of your research group, get your PhD or your master's degree, and you're not prepared to put in that additional work? In which case, what's the result of this paper that you've attempted to write? Are you going to try and submit it elsewhere in the hope that it may be published? Or are you going to be able to buckle down and do some additional work that really needs to be done in order to make it publishable? What about the choice of an outlet? There are hundreds of different ways that you can publish your research. I'm a professional chemist. Some of you may be chemists as well, and I just want to offer some general views on that. You want to look for a journal or an outlet. We'll refer to them as that because there can be lots of different ways of publishing, to ensure that it has a lot of readability. And so typically that's done through using an indexed journal, and you want to find an authoritative list, such as a master journal list, to make sure that whichever journal you choose, it's going to be widely indexed so that your work can be found. You don't want to be publishing a paper that is not going to be found and read. And so one point I would make here is to avoid non-indexed or low-indexed journals. You want to create a short list of journals from the particular research area that you're in. Oftentimes your library will be a good resource to help you with this. They can help you in person or virtually, and you can get articles from the library so that you can compare the typical quality of the papers that are published. And based on that, you can evaluate your list on a broad spectrum of qualitative and quantitative measures that I'll discuss in just a few minutes. A really critical question to ask is, does your work fit the scope and aims of the journal? Virtually every reputable journal has a list of aims and scope of the work that they publish, and you need to evaluate how your work fits in with that. What types of articles are published? For instance, some journals only publish review articles. If you're writing an original research article or a communication, then clearly that journal is not going to be the right outlet for you. So you need to consider the types of papers that the journal typically publishes. And then you'll also be able to get some metrics from most journals, such as time to publication, rejection rates, how the peer review process may be done, whether you want to publish in an open access journal, and in particular, what's the readership of the journal as well? Is the audience for your paper the right audience that reads the journal? So some of those metrics that are used are good and bad and need some further explanation. So often you might look at metrics for the journal that include the number of citations that papers get, alt metrics, especially social media coverage of papers, typically from authors themselves, usage, such as the number of downloads, the journal impact factor that I'll talk about in a minute, a perhaps overly used metric, and normalization of metrics so that journals appear to be using the same data. For instance, they're not using self-citation metrics as a way to look at how impactful they are. There is this over-reliance as well on the journal impact factor. And part of the reason of looking beyond that is that informed authors and institutions will look at metrics that are relevant and reproducible and justified and informed to make a decision about where to publish their work. You've got to be really on the lookout for predatory journals and conferences that are outwardly soliciting inputs from you. Those are typically not the places where you want to be sending your hard-done scientific research. And in particular, if you choose an open access journal as well, be aware of any article processing charges that there are, and especially be aware of any article processing charges that are not clearly stated. You don't want to have any surprises when it comes to if there's a cost to publish your work or not. I want to talk now a little bit about preparing your paper. So you've decided that you want to publish your work. How are you actually going to go about doing that? Well, the first step is what's the format that you're being asked for? Are you required to format your submission with the precise style and using a journal's template? Many journals do have templates that you can use to create a paper, but there's been a recent trend in format-free submissions. And the beauty of format-free submissions, which is actually which is the way that our journal does it as well, is that you can submit your paper in a style that you have prepared, as long as it is internally consistent. And I'll explain what that means in a minute. The reality is then, if your paper is accepted by that journal, then you'll have to make some modifications at the time of acceptance. And if it's not accepted, then you haven't put in all the time and effort necessary to actually create the paper in a particular format. That is, that you can then choose to resubmit it or revise it to a different style. However, format-free doesn't mean an inconsistent styling within the paper. It doesn't mean that you have not read or proofed your paper. So the takeaway message here is that format-free does not mean standard-free. It does mean that you don't have to develop your paper according to a specific style guide, although that may be required at some point in the future. It also means that you can't avoid all of the things that are required for a paper to be reviewable. And so that may mean including figures and tables and any supplemental materials. So everything needs to be included with even format-free submissions. One often overlooked information that you need to know about when preparing your paper is that the instructions for authors, which do come on journal websites and oftentimes in printed journals, do contain really vital information about what to include when you come to prepare your paper. The order of sections, the presentation of characterization of new products, for instance, what's expected in supporting materials, and notably things like the style that is used for citations, because again, journals do have some particular differences. There are many things as an author that you should be aware about when it comes to your responsibilities, what I'm calling here author ethics. Our journal, Phosphorus, Sulfur and Silicon, is a member of the Committee on Publication Ethics. And I've included the website there. We follow these COPE guidelines when dealing with potential acts of misconduct by authors. We as COPE members can often make a request for rulings and for advice on what happens in cases of misconduct. But my point here is that you should avoid getting into those particular situations. So perhaps as a summary point before I delve into a couple more details, don't engage in any opportunity to misrepresent results that are presented in your research. That's a critical point here. There are lots of things it can hurt. Your institution's reputation, the journal's reputation, you as a scientific writer, and in particular, the process that you have gone through in order to get to the alleged results that you have. We practice the scientific method in getting our results, and you don't want to have a spotlight shone on you because you have not followed the principles of the scientific method. An important point to remember as well is that work that you submit to a journal should be original and not published elsewhere, unless that work is an expansion on an existing area. And one of the ways that we often see this non-originality is in what we call text recycling, self-plagiarism, where large chunks of a previously written paper by you or the same group are simply copied word for word verbatim and put into a new paper. A few other do's and don'ts for you. So do only submit to one journal at a time and wait for a decision. It is unethical to shop your paper around to multiple journals at the same time. It is not acceptable for an editor to receive a message from you asking to withdraw the paper during the review process because, unbeknownst to them, you've shopped it around and you've got a decision that you like from a journal where you've submitted it elsewhere. That is not a way to proceed. It's also not acceptable to fragment work. If you've got a paper where you've made 15 new compounds or something like that, it's not acceptable to split it into two and hope that you can get two different publications out of it, whether it's in one journal or in multiple journals. Do always present your work with honesty, clarity, and without any data manipulation. That's the way that you'll run into mistrust issues if you do any of that. And it's also never acceptable to present work or data of others or ideas of others as your own. We call that plagiarism, without offering proper acknowledgements to the appropriate sources, and that those sources are given accurately. I want to talk about some of the best practices for success when it comes to getting your paper published. And many of these are based on the experience that I've had as 12 years as a journal editor. I do read the papers that come to our journal as well as those, the comments of reviewers and of course the editorial team that I work with. So one problem that I often find in introductions is that sweeping statements, either with or without citations, or this over-exaggerated claim that your research is going to change the world, are often made, and those statements are not necessary to include in a paper. Sure, there's value to your research, but don't over-exaggerate that value unless it's justified. Don't overly cite yourself unless there is a very specific reason to do so. If you are the only researcher who has been in this area and you are the one who has created the novel results, that's okay to do, but it is not acceptable to include many of your own citations as references to previous work. Don't guess at scientific and journal abbreviations. Use an authoritative source. I see a lot of common mistakes with incorrect abbreviations, even in things that should be got right, such as units and the use of SI units in particular. Don't expect to have your paper accepted unless you have corroborating evidence of all the claimed new compounds. And that I'll talk a little bit more about this with supplemental materials, but that means you will be expected to have included all of the NMR and high resolution mass spec data that supports how you have made and characterized the compounds that you have in your paper. Again, talking from a synthetic chemistry perspective. And also, don't expect work of a very narrow scope or a lack of novelty, or perhaps one that only changes minor components of a previously published research to be well received. Typically, reviewers are looking for something that goes beyond minor changes from existing work in the literature. Do use a journal's template if there's one available. Again, I talked a little bit earlier about format-free submissions, but many journals do have templates available, and they're useful to you because it can help you see in what a proof copy of your paper will look like as well at the end. I urge you to use a native speaker or a manuscript preparation service if you need help with your English. Our journal, for instance, only publishes in English nowadays. We used to publish in German and French, but we have not done so for a few years now. The most important reason for using a native or a manuscript preparation service is to ensure that your science is readable. It is very difficult for native English speakers to understand science if the language of and the writing is of low quality. What we publish are scientific papers, and those scientific papers have to be well written. One of the beauties of our journal is we are prepared to spend time with you after acceptability to ensure that that the language is right, but it's your responsibility to make sure that those corrections are done. It is also very important to include a detailed cover letter to the editor of the journal, indicating how the research is relevant to the scope of the journal, the aims of the journal, and why it's worthy of publication. So please take time to develop a good cover letter and address it personally to the editor as well. Do ensure that at the time of submission, you include all the necessary supporting information for your paper, and that would include NMR spectra, checked CIF files if you've got X-ray structures, computational files. The author and the reviewers don't want to be chasing those up after you have submitted the paper. And it's good practice to ensure that all of those files are included at the time of submission. Another key hint for you is that you should respond fully and thoroughly to the comments of the reviewers. It's not acceptable in a response to a revision on a paper, for instance, to say, we thank you for the referee's comments. We've made all the corrections. That's not acceptable. You need to respond on a point-by-point basis, because typically referees have spent quite a lot of time, of their own time, reviewing your paper in order to make it better. And you should acknowledge that with time taken to indicate what you've done specifically to address their concerns. I'm going to talk a little bit about our journal's work as well, phosphorus, sulfur, and silicon, and the related elements. We're published by a highly reputable publisher, Taylor & Francis, which is one of the top 4 STEM publishers in the world by quantity and volume and quality. Our journal was first published in 1976, and our 196th volume will be published in 2021. So we have a long history, 45-year history in publishing main group chemistry. We appeal to a readership in inorganic, bioorganic, and organic main group chemistry work, especially in catalysis, use of main group elements in reagents, and in novel synthesis. We also published quite a bit of non-classical heterocyclic chemistry. Our scope does not include classical heterocyclic chemistry such as known ring closures, but we do have a focus on synthetic chemistry through much of our work. we've also seen a lot of changing themes in catalytic and computational chemistry, materials chemistry as well, involving main group elements. And so we have expanded our scope to take into account the changing times in the world of main group chemistry. We have an impressive publication record. We are actively involved in publishing proceedings of relevant conferences for our readership. We have a very relevant, qualified and active editorial board consisting of about 30 members worldwide. We get together frequently, we talk, we interact, we stay up to date in our fields. One of the things that we are known for is our high quality author services through peer review. We are a helpful journal, I would like to say. We offer elevated help to get your work published. And we do that because we offer valuable comments back to you, and we understand that in some cases English may not be your first language, or that you need help with language services. And so given enough time and patience, we can often get papers to publishable quality, assuming that the science is good. So my editorial team is fully committed to consider all suitable papers, those that lie within our scope of work and that we deem to be suitably scientifically adept to be out for peer review. And I want to guarantee that you and your paper will be treated with dignity, equity, and respect. That is important to myself and our editorial team. All of our papers are submitted through our journal's Scholar One site. So this is a very common platform now for journal submissions. You are able to upload individual files, which are then assembled into a PDF, and the submission process, especially using our Express submission process, is very simple. You only require a few files, a main document and a graphical abstract, and of course supplemental materials as needed. All of those draft submissions are passed through a pre-editorial checklist to make sure that the files are complete and not corrupt in any way. We do check papers for plagiarism using Authenticate Cross-Check, which is a very powerful tool that editors use to identify both self-plagiarism and plagiarism from other original and published work. So there is a plagiarism index that comes with that, and editors can easily check to see how much previously published material is contained within any given paper. We're proud of the fact that accepted papers appear rapidly on our website, and we still offer a print version. We print 4 bound issues per year, quarterly, and our website papers are in full color and in print up to 4 colors as well. So that concludes the comments that I have for you as young science writers who are looking to get your work published in a scientific journal, whether it's our journal, Phosphorus, Sulfur, Silicon and the Related Elements, or other journals that you decide are the appropriate venue for your work. I'd like to thank you very much for taking the time to listen to my talk today. Again, my name is Martin Rudd. I am the editor-in-chief of Phosphorus, Sulfur, Silicon and the Related Elements. My journal email contact is up on the screen, and I, of course, would be very happy to hear from you if you have any questions about this talk and have an opportunity to work with you should you choose to submit to our journal. So again, thank you very much to the organizers for giving me the opportunity to present today. I wish you a successful webinar, wish you well in your scientific careers as well. And please don't hesitate to reach out if there's anything that we can do to help. Thank you.
Can you hear me, Professor Yoshifuji?
Yes.
Welcome, hearty welcome.
Oh, yeah.
Raki, proceed further. What happened? Hello.
Hello?
Who is the next? Talk is over.
Martin.
रितेश कोविड से सीट गई
कर रहे हैं
नहीं तो आज खत्म कर दीजिए यहाँ पे कल
Good afternoon, everyone. I apologize. There was quite a bit of a technical glitch, which has now been sorted. In absentia, we would like to thank Professor Rudd for giving us quite a lot to think about in terms of getting our research published and so many different ways in which this particular presentation has been useful to experienced researchers and students alike. We now come to the third speaker of the day, Professor Sandeep Verma. He is currently serving as Secretary, Science and Engineering Research Board, SERB, which is a statutory body established through an Act of Parliament 2008 with a mandate to support basic research in emerging areas of science and engineering. As a premier national research funding agency, SERB is significantly responsible in raising the quality and global footprint of Indian science and engineering to the highest competitive standards achieved through calibrated financial support for research and development activities. Professor Sandeep Verma is professor at the Indian Institute of Technology, Kanpur. His research group works in the areas of ordered peptide assemblies, metal-mediated nanoscale systems, programmable soft matter for neuronal regeneration, novel antimicrobials, and small molecule stem cell modulations. He is a recipient of Shanti Swarup Bhatnagar Award in the year 2010 and an elected fellow of the Indian National Science Academy, INSA, the Indian Academy of Sciences, and the National Academy of Sciences, India. We welcome you, Professor Sandeep Verma. Please take us on the journey of project writing.
Good afternoon, everyone. Are you able to hear me?
Yes.
Yes, sir, absolutely.
All right. So thank you very much for this introduction. And I'm sorry, my apologies for a slight delay. I was in another VC. So I'm truly gratified to have this invitation from Chancellor and from Registrar IIS University to this wonderful initiative, this webinar, where my plan today is to share with you how we go around through the process of project writing, which is specifically positioned from the standpoint of Science and Engineering Research Board. And I hope that some of the faculty members, who are young, and some of the prospective faculty members, especially younger students, would find this conversation, this webinar, useful for their future endeavors. So if it is okay with you, Dr. Rakhi Gupta, I'm going to share my screen. Please let me know if you're able to see my screen.
Yes, it can be
Yes,
seen.
sir, of course.
Yes. So what I'm going to do today is tell you a bit about, from SERB standpoint, what we look for in project writing, what are the various stages of conceptualization of a research problem, and how one can implement once the projects are awarded. And it was, as it was pointed out in a very elaborate and kind introduction, that I'm currently associated as Secretary of Science and Engineering Research Board in India, which is part of Ministry of Science and Technology. And also I'm a professor of chemistry and chemical biology at Indian Institute of Technology, Kanpur. So let me tell you a bit about Science and Engineering Research Board. And as some of you would know about it, SERB is a statutory body which was formed by an act of parliament, working under the Department of Science and Technology, Ministry of Science and Technology. So we were conceptualized or brought into life in 2008. And currently we are one of the premier funding agencies in India where you would like to submit your project for research funding. So we pride ourselves for a versatile funding management system where we look at research funding, we monitor and we evaluate everything through very high standards of practices by applying modern science management procedures, whereby we cater to almost 1 lakh principal investigators across India. And our online portal, which is SERB Online, is one of the foremost project transaction platform available in science ministries, which is seamless, which is user-friendly, and it allows us to work with the ultimate discretion of integrity in terms of managing the projects and also in terms of releasing money and managing your project. So what is our USP? Our USP is basically to create a high level of synergy between academic institutions, between R&D laboratories, and between industries or through industries. And this is achieved with the help of multiple programs, with very many awards that we offer to celebrate excellence in our PIs, and also the fellowships that we try to support our youngsters, our postdoctoral fellows, our young career awardees. So in addition, we also offer what is called as the travel and conference support if you are going to present your research to high-level conferences abroad, or if you wish to travel to these countries to present your work. If you were to look at a research schemes portfolio, I have tried to make it as simple as possible so that without really taking too much time, I can still tell you the gist of what SERB does. So if you were to look at our basic verticals where we operate, we are a premier funding agency, as I had mentioned, where we offer research grants. We also offer fellowships and awards. We are responsible for science outreach, and we also offer you an interface with industry through very many programs. So if I were to go through some of these programs and allow me to take out laser pointers. So in research grants, we are looking at core research grants, which could be anywhere from say 30 to 40 to 50 lakhs to several crores. Startup research grant is specifically for our young researchers who have just joined an institution in all areas of investigation. They are given what is called as the startup research grant of SERB, and a very niche program has been created in SERB where if your idea is wonderfully blue sky, if you're looking at a very challenging problem, you can approach us for a research grant under what is called as SERB Supra scheme. We also look at fellowships and awards where we offer JC Bose Fellowship. We offer Ramanujan Fellowship for our young Indians who are doing postdoctoral fellowships abroad and are ready to get back to their home country with the help of Ramanujan Fellowships. For Indian diaspora and for foreign researchers, we offer SERB Vajra fellowships and SERB Star fellowships, which is Science and Technology Award for Research, that is offered to celebrate excellence between the age group of 40 and 50. And it is an annual call which you can have a look at our website and apply according to the eligibility requirements. We also look at outreach philosophy. We have very strong outreach philosophy in terms of reaching the last research investigator in the country through our equity and empowerment strategies, which are for the weaker section of our society. If you are working in colleges, if you are working in institutions which are lesser endowed in terms of equipments, in terms of infrastructure, in terms of facilities, we offer a fellowship which is called, or a project which is called as SERB Tare. This Tare is for researchers in colleges where they can get involved with better established laboratories, and they can still germinate their ideas, they can execute their ideas to completion. And finally, we offer, as I had mentioned, seminar and symposia support as part of our outreach initiative. We try to provide a very strong industry connect with the help of SERB Tetra program. Tetra stands for Tech Translation Award. So if you have a patent, if you have intellectual property that has been generated through SERB support, we very much welcome to give you unrestricted funds such as 60 lakhs or 80 lakhs, where you can use this money in an unrestricted style or an unrestricted financial arrangement to bring out your idea, bring out your patent, bring out your intellectual property to a product, to a level of product, and then you can spin it off with the help of startup money that is offered by other division of DST. We also have FIRE program, which is Fund for Industrial Research Engagement, and we have Imprint with the help of Ministry of Human Resource Development, which is now called as Ministry of Education, where we run the Imprint program, where academic institutions are supposed to interact with industry, bring out an excellent idea, excellent proposal that is funded by SERB and Ministry of Education combined. If you were to look at a bird's eye view of what we have done in, say, last year, SERB handled close to 35,000, more than 35,000 submissions, where we were able to give you 2,500 fellowships and about 11,000 sanctioned in all areas of investigation, all areas of our programs that was supported by SERB. So without going through these numbers, this already tells you the kind of footprint we have across the research platforms, across the research programs. And we very much welcome all of you from IIS and other places, whoever is tuning to this webinar, to look at SERB website, look at our programs, and engage with us to help us support your excellent ideas, help us support your excellent research, and take the nation forward. So just to top it off, we are a very strong agency reaching about 1 lakh investigators. We crowdsource disruptive ideas. We support them to the fullest extent, and you'll be satisfied. You will be satisfied by our efficiency of e-management of projects and finances, which will happen once the project is awarded. So what I'm going to do today in next 20 minutes or so is take you through the sort of life cycle of how a project is written, life cycle of how an idea is germinated, and how you begin with in writing a project for one of the premier funding agencies, so that your idea can be taken up by our advisory committees. That can be taken up in a very sort of favorable fashion, so that you can get money for your research. So when you look at extramural projects, we are looking at 3 pillars basically, which is the investigator, the competence of investigator, and the research focus of investigator. So if you were to start with principal investigator, the PI needs to present, when you are writing a project, PI needs to present a compelling argument why you are writing a particular project, what is your prior training, how independent you are in terms of your originality, in terms of presenting your idea, which should stand apart from your doctoral and postdoctoral work. Then we look at your competence, that if you are proposing an idea, it should be supported by the core competence of PI and your ability to address outstanding research problems. So all these 2 points will be looked at by the empowered committee. And finally, we have to be assured that the research focus you have chosen is contemporary in nature, that it is very modern, yet fundamental. It is blue sky, means you're trying to do something very, very different, dramatic, yet it is grounded to fundamental principles of science and engineering. It has to be cutting edge. It has to be disruptive, exponential, and translational in nature, so that the research money that is invested through the taxpayers' money comes out in a very different way, not only generating research papers, but also generating ideas and intellectual property that can be translated further to startups, to spin-offs, and so on and so forth. Let us start with the project life cycle, the stage 1, which is how to conceptualize a project. And in this, I would like to bring in a very interesting quote by Paul Dirac, who was the Nobel Prize winner in physics in 1933. The measure of greatness, I mean, you can read it. What exactly it is being said in this quote is that the scientific idea should be stimulating. It should be able to open new lines of research. So whenever you are thinking of ideation or thinking of conceptualizing a project to a successful research outcome, you should importantly look at the fact that whether it is exciting enough, whether it is going to open new lines of research. And that is where the originality, the conceptualization of the problem begins, which has to have some novelty, some relevance at the national level, and also make your institution and India competitive at the global level. So that is conceptualization of the project. And if you were to expand it out a bit further, you would find that the entire process of conceptualization has to go through several cycles of initiation, overview, ideation, and so on and so forth. So first one is initiation, where you have to look at, or you have to think about or choose a research problem which is of high value. High value research problem is to be chosen. You have to learn about the scope of your research problem. You have to figure out, if I have chosen this research problem, what are my knowledge gap areas? What are the knowledge gap areas in this particular domain that I can answer with the help of my competence? And that creates the next level, which is ideation of the research problem, making a problem statement, and then bringing out, sort of sectioning your problem statement in terms of short and long-term objectives. So in first few months, first few years, you are going to do, or you're going to accomplish these many objectives, and eventually it will pan out to a long-term benefit for the research ecosystem in India. And once this is said, then we are ready to articulate the objective by intertwining them. The few objectives that you are going to articulate in your ideation stage have to be intertwined. Your bullets, your short-term and long-term bullets, have to have a relevance or a codependence with one another, and by the same time, or at the same time, connecting the gap areas which you have to articulate when you are writing a proposal. And finally comes the elaboration. Once you have intertwined the objectives, once you have learned about the gap areas, then you try to develop an experimental plan, or it could be a theoretical project. Yet in that theoretical project, how you wish to take your methodologies, how you wish to employ supporting studies to support your idea, to develop an experimental plan, comes at the elaboration stage. And that's when you are really ready with the conceptualization and writing up of your project. Now, when we give lectures, when many young colleagues interact with me or with SERB, they always ask a question that for the longest time when they were doing PhD or postdoc, they were applying their thoughts, they're applying research ideas, but they never were involved in writing a research project. So they are at times little doubtful that how to search for a research problem, because you have always worked for a very fantastic doctoral supervisor, a very impactful postdoctoral supervisor, but you never got a chance to sit quietly and think of what could be a good research problem if it has to bear my name. So if a research problem has to bear your exclusive name, you have to search for a research problem which is away from your prior work or from your prior research studies. So I have given you four sort of verticals here, the way you would go around and look for a research problem. The one way could be that you look at a hypothesis-oriented research problem where you would look at significant and unresolved research problems where you do not still have enough material available, yet there is a focus, there is a direction which when applied could give you fantastic results. So that's a hypothesis-driven research which has a very strong deductive reasoning to your articulation, to your conceptualization of research problem. Another level is that if there is a problem statement available in literature, how innovation can bring the novelty in that particular research problem that is going to be driven in a way that you get a forward movement in that particular field, which if the field is well established and you are trying to bring in innovation in that particular field, knowing the gap areas that exist. So once you know the gap areas, once you know what kind of innovation you can bring from your background, your experience, then you are ready to implement innovative ideas. The third one is a non-incremental and risky research problem. And here I would like to draw your attention to SERP Supra. When we created this program, SERP Supra, we were actually telling investigators in as many words that we want a research statement where you think there is a good amount of chance that you will fail in your project. But you have to convince that even though you will fail in the project execution, but your idea is so risky, if it is going to be successful, then you are going to put India on the map of global science and technology. So this project was, or this scheme was conceptualized to avoid routine and predictable proposals. Do not present us routine and predictable ideas, and you have to bring in very difficult, extremely difficult and challenging research problems for execution, which are not possible otherwise. And finally, you have to create a signature. So to all my young colleagues who are listening to this webinar, it is my urgent or sort of serious suggestion to you that always try to do something which is different than what you have done before, so that at national level as well as at the global level, you can create a signature based on your own creativity, based on your own ideas and originality. And your problem should be of such a way that once you have gotten the funding, it can last up to 6 to 10 years so that you can really create a signature within the research community. What are the other ideas of research and problems? You could be reading voraciously, if you will, of research papers, literature, to find out outstanding questions of high value. You should always attend lectures by experts, webinars, and where the research areas is not even of your direct interest, but you may find something which is of laterally connected to your own research ideas, and that can make your ideas, that can make your own research very relevant and very contemporary. You can think of blue sky ideas, as I had just mentioned, long-standing hypotheses, theoretical propositions. So you bring in all these components and then create a top-down research calls in new and emerging areas, which can give you enough money or funding support to execute your own research. Finally, I'd like to mention that it is always a good idea at times to think how your research is going to be aligned with national missions, with developing global research synergies such as FAIR, LIGO, LHC and 30-meter telescope TMT, where India is involved, and India is investing very, very heavily in such kind of international research projects to bring in research synergies that is going to benefit our research investigators. So the question is that do all research ideas bring in something of value that could be of commercial interest? The answer is yes, because I have given you one example of DNA amplification and polymerase chain reaction. I draw your attention to a research paper which was published in 1971 by the Nobel laureate of Indian origin, Har Gobind Khurana, where he described, or his research group described, a repair application of synthetic DNAs, which was catalyzed by DNA polymerases. Now, this idea went unnoticed for a couple of decades before Gary Mullis picked it up, brought it up to the level of translation such as polymerase chain reaction, and he showed that how minuscule amounts of DNA could be amplified with the help of what Khurana had proposed to give you polymerase chain reaction. And this polymerase chain reaction was so dramatic, it changed the landscape, that it fetched Nobel Prize in Chemistry for Gary Mullis in 1993. And since then, there is no looking back for PCR. It is now used in cell and molecular biology, forensics, agriculture and conservation, medical sciences and diagnostics. And if you can recall, the current diagnosis of coronavirus is revolving around the polymerase chain reaction that was discovered long back. So from an idea in 1971 to a finished product such as PathoDetect, made in India, right? It has come a long way. So you never know when you are executing a research problem, when you are trying to bring out a new hypothesis, 10, 20, 30 years down the road, it can end up being one of the fantastic discoveries, fantastic inventions, and eventually a product which could help the society, which could be so much, it could be beneficial to the society, right? Now we come to what is called as project life cycle in SERB lingo. When you are writing a project, when you are trying to explain your objectives, and here again, I'd like to quote you Santiago Ramon Cayal, his quote, who was a Nobel laureate in physiology or medicine, that all outstanding work in science or otherwise, it starts with immense zeal and it starts with a great idea, right? So we have to always bear this in mind while you are introducing, explaining, and justifying a research problem to your peers when they are going to read your research project, when they are going to evaluate your research project vis-a-vis what exists in literature, what evidence is there that you're going to be successful in executing this project. And that is your project life cycle when you are about to begin writing the project after you have ideated it, all right? So clear articulation of the project is necessary to answer the question why, right? Then you have to tell your reviewers, you have to tell your committee members that what is known in this research area or in this domain. So you have to have an overview of idea and its current status. You have to then spell out the objective. And one thing that is really important here is that you have to use simple terminologies. You remove all non-jargon phrases, and you should not overstretch your objectives beyond the duration of the project. You have to also bring out what is the originality, why you are the first one to address such a problem with such an approach. And then you have to paint a big picture that what are these efforts and where are they going to lead you to once you have the desired outcomes at the end of the duration of your project. So painting of a big picture is extremely important to convince reviewers, to convince committee members that you should be given money, and it is indeed an excellent idea which should be supported by federal funds and sort of given to you for execution. So the take-home messages from a new proposal for anybody who reads your proposal should be that it should be convincing that the competence is unquestionable, objectives are worthy, and the work plan is very robust. The key elements that you want to pay most attention is the problem should be modern, the plan, methods, and deliverables should be in sync, or they should synchronize with what you are proposing as a problem. The novelty and originality is extremely important, while it is also important to convince your peer reviewers that if for some reason you are going to fail in your idea, fail in your execution, what is your plan B, how you can recover the project, what else can you do in this area if your original ideas are not going to work. So sometimes it is good to articulate a half a paragraph, one paragraph of plan B. And always you remember, if you have an excellent idea, but if you do not know how to write, it is likely to be rejected. So all poorly written good ideas are likely to be rejected. So you please make sure that you spend time to read literature, you connect the dots well, and you create a footprint in terms of a project, a written project that could be picked up by the committee as an excellent project for funding. So once you have written the project, actually it goes through 3 levels of analysis. Believe it or not, initially it is self-assessed by you. You know in your heart whether you have written a good proposal or whether you have written a proposal which you want to just send it out to the funding agency. So you in your mind would be doing a SWOT analysis. What is the strength? What are the strengths, weaknesses, opportunities, and the threats available in my project? Because if you do not do it, it is going to be done by the reviewers who are going to review your project. And it is also going to be done by the program advisory committees who are going to read your project. So it is important, if you have a good friend, if you can convince a friend, or if you believe somebody who can read your project, give their frank opinion about the SWOT analysis on your project, you can still make your project better. You can still make it more competent, more tight, more believable before you upload, before you send it out to the funding agency. So if you have sent your project to SERB, the project decision path is fairly straightforward. We announce research calls. So a whole lot of research calls are announced around the year. You are going to read these research calls, and eventually you are going to apply against one of the program. And once you have applied against a program, we have program advisory committees, and these program advisory committees are discipline wise. So we also have the presence of early career reviewers, young investigators, young women and men researchers, so that they also get to know what is the process. Because often we get a complaint that, young people are sidelines, they are not made part of the decision-making process. But since I have joined SERB, I assure you that a lot of younger colleagues have been part of the program advisory, giving comment on very top-end research programs such as Supra, Vajra, and Imprint. And finally, SERB believes in transparency. We have online workflow of ideas, financials, and wherever there is a conflict of interest, wherever there is a conflict in ethics or oversight, we have the right committees to look after that, and we ensure the highest level of honesty and integrity in giving a decision. Finally, the stage 3 of managing the project is, if you have done everything, if you have gotten the money, you start managing your project. You create a baseline that I am here. My research program starts from here. My research money is going to be spent in this particular fashion. You always make sure that you frequently assess your performance with realistic parameters, and you benchmark your outputs. Every 3 months, you should assess whether you have done enough in 3 months as part of your research program. And if it is not working well, then you slowly move to plan B to make sure that you have at least some data, some results at the end of the duration of your project. So once you have gotten the funded project, you want to manage it, you initiate the project in your institution, you define the project goal, discuss with your co-workers, your students and postdoc, and you start creating protocols, briefs and reports. Then you plan, You assign the roles to your team for a phased out execution. You want to also stick on the timeline, as I mentioned, so that your studies, so that your research stays on track while executing, while managing the resources, while managing the time, by managing your group. You should have a forward movement. So it is very important at this stage that the principal investigator provide the right kind of mentorship to PhD students and postdoctoral fellows. Finally, you monitor them closely. You should monitor what are the goals, whether the deliverables are met, and what is your team performance. What is your, if you want to recalibrate your objectives, if you want to iteratively execute your research problem through another method, or there is a different route that you can take to execute research problem. And finally, you are getting close to the closure of the project, where the duration of the project is over, and you are going to consolidate data, write papers side by side, and do a whole lot of other things before you are ready to submit a new project. So if you were to look at this from a bird's eye view, the research conceptualization and implementation, if here is the time scale, right? You move from left to right in time scale, starting with pre-project ideation, that I call as initiation stage. Then you ignite, then you put it in words, you start writing, you finalize the research plan, your project plans are finalized. That is stage one in your proposal writing, when you have almost but gotten the money and you're ready to move on to stage stage two. Stage two is planning. You plan the methods, you plan the iteration, then you execute them with your objectives and the resources that you require to execute your project. And you move into monitoring, where you would like to look at the deliverables, which are going to be necessary to show it to the program committee that in 3 years or in 5 years, what kind of deliverables you have achieved. And you have to recalibrate your research problem if it is not working out. And of course, here and in the extreme right, you can easily see how are the work going to be distributed between PI, team, and the kind of allocation of work that is contingent upon the investigator, that you assign right job to the right person so that you ensure the right or the correct execution of your research project. So the final slide is that project writing is not just packaging of ideas. So if you have a couple of ideas, if you have few ideas, it's not that you just bring them in one document, but you are also trying to look at how to create a very convincing proposal that revolves around outstanding questions. So a convincing proposal revolving around outstanding questions that uses foundational knowledge, that PI should have their own foundational knowledge to build upon this proposal, these outstanding questions, using innovative methods, using innovative methodologies that could be theoretically based, that could be experimental methodology, with a clear set of deliverables in mind. If you have everything in one place, if you have good ideas, excellent questions, good knowledge based, and your research methodologies are very innovative, and then with all these you can tackle clear deliverables, so that at the end of the day, when you are done with your project, when you're about to submit a paper, submit a final report, you would leave a significant mark in your discipline. So with these little the smaller set of objectives, the researcher has to move forward all the way from ideation of a project to delivery of result, so that eventual goal is to create a signature. Eventual goal is to create a significant mark in your discipline. And that is what I would like and urge all investigators, young and old, when you approach SCRB or any such funding agency, that should be your motto, that should be your goal. And with these words, I close my brief presentation. I would like to thank all of you, specifically Dr. Rakhi Gupta, Dr. Manisha Patni, for your very kind invitation. And thank you all for tuning in. And I'll be very happy to answer any question if you have. Thank you very much.
Thank you very much, Professor Verma. We've greatly enjoyed your presentation. And I think if you access the chat section also, you'll see so many comments by a number of our delegates and researchers, all of whom have greatly appreciated your presentation. So thank you very much, sir, for talking to us about project writing in such great detail.
Very well.
I now open up the webinar to a short Q&A session. Unfortunately, we are facing a slight paucity of time because we're keeping to a schedule, but we would like to take in a few questions for our presenters. You may please type your questions in the chat box, and I will ask them for the presenter that you mean them for, but please do not speak them out loud. Thank you. Professor Verma, I will ask you directly, do you have time to take questions, 1 or 2 questions, sir?
Yeah, I'll stay back for another 5-7 minutes. Yes, no problem.
All right, all right. Thank you, sir. Thank you.
Sure.
All right, we have a few questions coming in, a few comments coming in also. I think one of the main queries towards you, Professor Verma, is that we would like access to your presentation, which has been very informative, and there's been a request for that specifically. A general question has been asked, what is the key difference between the role of PI and co-PI?
So the PI is the individual where most of the ideas originate. And if I were to think of several set of ideas to write a proposal, I will be the PI. And if there is an additional expertise needed, to augment what is being proposed in this particular research project, then that individual becomes co-PI. So it is not always necessary to be a co-PI. You could be a collaborator, but when you become a co-PI, you are actually putting your signature on the document that you share the ideas, you share the objectives, and you are equally responsible for executing the research problems and deliverables. So there is a subtle difference between PI and co-PI. PI is the champion of the proposal. Co-PI is in the supporting role, and you have collaborators who are not directly part of the proposal, yet they are trying to solve the problem by the side.
I see. Thank you, sir. A question has been raised by Professor Vijay Singh. He says, for international conferences proposal, what is the main thrust? Apparently, they tried to apply to SERB 2 times but could not get in. So this is the main question that they have.
So with due regards, I'm sure I think your proposal must be strong, but it's just that at times, everything is graded on the curve. It's like any other allocation of a funding source. So what is important here is that you have to make sure that your research seminar or your conference has the right kind of theme. Theme is important. It should be contemporary. You should not be organizing a conference on a very jaded out topic. So we always look at good topics, emergent topics which are of high contemporary interest. That is point 1. Point 2 is that you should have excellent speakers, because one of the major reasons to organize conference is not to call people to your college and university, but to expose your students to the best possible experts available in the domain so that they all can benefit. So you have to ensure, because we also ask for speaker list. So your speaker list should be stellar. And all of us, I am a teacher, I have no problem in going to any university to deliver a talk, or others as well. More accomplished researchers will also come. So you please ensure your speaker list is good, your topic is topical, and I'm sure that next time when you apply with these little pointers, you will be successful in securing funding from SERB.
Right, sir. Right, sir. Thank you. SD Samant sir is asking, are we giving a lot of unnecessary stress on deliverables?
Yeah. I don't think that's a right question. When you are getting federal money is money coming from taxpayers, then you have to deliver. The whole purpose of being a professor is you deliver good lectures, you impart the best possible education. So I am unabashed about it. I will not be apologetic. Deliverables are important and deliverables are critical. If you use public money, then you are responsible, you are answerable to SCRB for your deliverables. And otherwise, you use industry money, and you believe me, industry is going to be even more stringent when they ask for deliverables. So this question is not proper. Deliverables are important, and we are committed to having the highest quality of deliverables.
Right, sir. Thank you. Anuba Jain is asking a question. There is a suggestion that there should be some feedback about rejection of any proposal. It would help in improving for the next time. Your comments on this, sir?
If I got the name right, Ms. Jain, is it? So,
Yes.
so what we do is, Ms. Jain, the proposals go through at least 2 to 3 levels of scrutiny. First level of scrutiny is if the proposals are not good enough to be put through the review cycle, they are rejected at SCRB. And then all what we do is the investigation modern, it is not urgent, and we are not going to process it any further. It is similar to if you submit your research paper to top journal, say Nature, for example, right? Sometimes they just return the paper, that paper is not good enough, please submit it elsewhere. So we want to give you the first cut very quickly. Second level is we get to reviewers, and I would like to believe that all rejected proposals get at least 2 to 3 or maybe 10 lines of the reason for rejection, which is very important. See, I am also an investigator. I come from IIT Kanpur. My whole research group revolves around having sufficient support for research, right? So we all look for the rejection. So we do attempt to give a rejection, reasons for rejection to all investigators individually. But for some reason, if you have not gotten it, there has been a problem, you are welcome to write to us. I shall look into the matter personally.
Thank you, sir. There are 2 questions regarding PI, which I will put together. They are, of course, individual questions, but I will ask them together. Does PI need to be applied through the university, through the institution, or can it be applied individually? And also, instruments that are approved, can they be installed in the co-PI's laboratory?
So the submission of proposal has to happen through an institution, because money released is to universities, money is released to colleges, to any research and development laboratory which is registered with SCRB, because you are getting public money. So public money cannot be transferred to individual accounts. It has to go through a college. It has to go through an academic institution. So yes, the answer is you have to route it through a university, even fellowships. If you are studying abroad, if you are doing postdoc fellowship abroad and you want to apply for Ramanujan fellowship, you would route your application through an institution who is willing to take you as a Ramanujan fellow. So that should answer your question number 1. And question 2 is that we have no compulsion that equipment has to be in PI's laboratory or co-PI's institution, but it has to be mentioned when time. If it is if you're facing a problem, then you can get explicit approval from SCRB and you can install the equipment at another location than what you had asked for. That should not be a problem, but it has to come with a approval by head of the institution, because head of the institution is the one who would tell us that we are willing to provide infrastructure facilities of, for example, air conditioning for uninterrupted power supply and so on and so forth. I hope that answers your question.
Yes, sir. Thank you, sir. I think we'll take one last question from one of our students, sir. She's asking if the project is unique and has an equal possibility of being either successful or unsuccessful at the end, what are the chances for it to be accepted, and in what capacity does SCRB encourage such proposals?
So as of now, depending on which area you are working in, the success rate stands around about 20%. About 18 to 20% proposals are accepted. So out of all 100 research proposals submitted, 20 gets approved. And I hope that the person who has asked the question would write such a strong proposal that we are going to, they're going to be successful. But I would use this platform, if you have a half a minute, to popularize one program which we have just launched, which is called as Sir Power. Some of you may have seen about it. This is a program specifically for our female researchers, because we found out that out of all proposals, the success rate for female researchers was rather low. So SCRB has created a platform which has been just launched by our Honorable Minister for Science and Technology, Dr. Harshvardhanji, which is called as Sir Power. Power stands for Promoting Opportunities for Women in Exploratory Research. So this program is only going to cater to female researchers. So we are trying to create a larger base for our investigators. We are trying to bring in gender parity so that the weighted opportunities for our women and female researchers are going to be made equal to their male counterparts. And what I wish is that in coming years, we are going to be successful in creating a very healthy ecosystem where large number of proposals from both male and female researchers are going to be successful.
Thank you, sir. I'm quite sure that with such visionary leadership at SCRB as yourself, a number of us are going to be motivated to take part in the various activities and various possibilities that you have put forward to us here, especially as you outlined during your presentation. Thank you so much, sir, for being a part of this conversation.
Thank you very much. I was very happy to be here. Thanks to Dr. Rakhi Gupta for this very kind invitation. So if it is okay, Dr. Gupta, I'll log off.
Thank you so much, sir. Despite your busy schedule, I mean, we know today you were busy in one of the PMO meetings, but then you still, took out time to address the delegates. I mean, this speaks, volumes of your commitment to promote research. Thank you so much, sir. And we always look forward to your support and help in the research endeavors. Thank you, sir.
Thank you very much. Thank you.
Right. With that, we have successfully come to the end of our first technical session. It now only remains for me to hand over to Dr. Pragya Sinha, Convener and Head Department of Chemistry, IIS University, to offer a vote of thanks for the first day of the International Webinar on Scientific Writing.
Thank you, Priyanka. Namaskar. On behalf of all the staff and students of IIS deemed to be university and Association of Chemistry Teachers, I extend a very hearty vote of thanks to all the speakers and guests for gracing the event today. A very big thank you to Professor Keglowicz and Professor Sandeep Verma for their excellent informative lectures. Professor Keglowicz guided us on development and refinement of results during research, whereas Professor Sandeep Verma gave an insight to functioning different research schemes, fellowships, conceptualization of high-value projects, SWOT analysis of a project, and creating a convincing project proposal with clear deliverables and innovative methods. I also wish to express my gratitude to Professor Martin Durad, who, in spite of being on his family holiday, provided us with his informative recorded lecture on publication of research, which guided us to go for preparing a paper for successful submissions and publications.
Pragya ma'am.
I also extend my thanks to Professor D.V. Prabhu, General Secretary, ACT, Professor Brajesh Pare, President, ACT, Dr. Ashok Gupta, Chancellor, IIS deemed to be University, Professor T.N. Mathur, Vice Chancellor, IIS deemed to be University, Professor Pradeep Bhatnagar, Dean Science, IIS deemed to be University, Professor K.S. Sharma, Advisor, IIS deemed to be University, and Professor Rakhi Gupta, Registrar and Secretary, Central Zone, ACT, for their enormous cooperation whenever required. A very, very special thanks to Professor R.K. Bansal for his non-ending support since the inception of this event. Without him, this event could not have been possible. Finally, I would like to thank all my colleagues and the technical team for their unconditional support. A very big thanks to Harwan sir and Suresh sir for their constant support. Once again, I want to express my gratitude to all the dignitaries on that platform from India and abroad for being with us this evening. It was a great pleasure to be with you all. Thank you once again. Again, we shall be having interesting lectures tomorrow starting from 3 p.m. We wish to see all of you tomorrow. Please join on time. Thanks and welcome once again. I would like to give a very important information that a feedback form is there on the chat box and it will be live till 6:30 p.m. So it is requested to kindly fill the feedback forms and applies. Thank you once again. Thank you.
Just to share with all the delegates. So tomorrow again, the session will start exactly at 3 o'clock. So we look forward to you all joining the session. So please join. The hosts will join in at about 2:30. But the session will start exactly at 3. Thank you. Thank you so much for joining.
Right, everyone. So we finally come officially to the end of the first day of the webinar or international webinar on scientific writing. We're very pleased that so many of you could join us today and participate not just in the inaugural, but also to stay through the 3 wonderful speakers and their presentations for the first technical session today. We are hoping to see all of you again tomorrow at around the same time for the 2 technical sessions in which we will be listening to 4 speakers altogether before we end the day for the 2-day international webinar. Thank you all once again for joining. We look forward to seeing you again soon.